Good evening. It's Tuesday night here on DJN TV. Thanks for watching. You know what it is? It's Tuesday night with Ben Stowe night. Ben, good evening.
What's going on?
Hey, it's great. We're back. We're in the office. We're doing things. And, well, you got a lot of stuff in front of you there tonight.
You know, yeah. I now that we have a Facebook page, which thanks for putting that up, by the way.
Yeah. It's like, how many, we've done 30 or some episodes. It's like we probably should have a Facebook page.
Yeah, and almost instantly, it goes to over 300 likes, and that I was pretty excited about that. So I feel like I owe those 300 people and however many viewers we have, I feel like I owe them a little explanation here. You mentioned all this stuff in front of me, and somebody asked me, what we do to prepare for the show. And I feel like I should probably just come clean on that.
Don't do it. Don't do it.
Yeah, I feel like we owe it to, now that we're official and all that. So here's the deal. We start shooting about 8 o'clock. And that gives John a little bit of time to edit, insert some pictures that I might send him. The preparation starts about 7:30 when I leave my house. I drive to the office. I get here about 1:45, and then I say, what are we doing today? Power. Okay, yeah, because we decided that about noon this afternoon. I'm going to run around and find a whole bunch of power-related stuff. So somebody said, what kind of research do you do? I hope nobody wants their money back because it's a free show, but none, I don't. And somebody said, do you have a teleprompter? No. It is what it is. So I just felt like I owed everybody that explanation that, you are such a great host because you really have no idea what I'm going to put out on the table in front of you. And I probably don't either until I start pulling these things off shelves. And luckily, we have a great big playground here at NLFX, and I just kind of run around and grab stuff. So
we just let them look behind the curtain, Ben.
Yeah, there's the curtain.
There's the curtain right there.
Yep.
Oh. Well, as part of our Tuesday night show, we'd like to check out the T-shirt of the week. And I see that we have a different one. I haven't seen this one. So show us, what is our T-shirt of the week?
We do. I just got this last week in Dallas. And it is, as you can see, I'm licensed to freak. I don't know, freak out, I guess. But obviously it alludes to radio frequencies. And, of course, there's still the struggle between licensed and unlicensed users and all that sort of thing. But anyway, I got this from a friend of mine who does radio frequency coordination. Anyway, so
cool.
Free shirt.
I like it. And it's got the cool microphone. It kind of looks like my microphone. So it's
absolutely, yeah.
It's awesome and cool. Okay, well, let's talk about what's in front of you. For those of you who now know the secret to the show, today at noon we decided we're going to be talking about power because people have asked about power conditioning. And I mentioned that to Ben. And, as a lot of you who know Ben, you can give him a good idea and he will take it not just a little bit. Not just a little bit. Yeah.
Kind of like 5 minutes to 8 when you said, are you ready? And I said, I'm taking apart power conditioners.
Yeah, and that's what you're seeing in front of him, ladies and gentlemen. Ben, let's start out. As I started with the DJ world, I was wanting to get into power, getting something to condition the power. Why was that important to me? Or why should that be important to me when I'm first starting out to get into something that will condition power?
Well, first and foremost is, we live in a first world country, the greatest superpower in the world, but we still have vulnerabilities with our power grid. The vulnerabilities with our power grid are substantial enough that actually the Department of Homeland Security has this on their radar, saying our grid is vulnerable. I don't want to get into any kind of apocalyptic type prediction, but the fact is that we do have, that's neither here nor there. Solar flares and yada yada, whatever. But that's not a problem we're going to solve on this show today. So
that's next week's episode, by the way. Tune in.
We can do it. We've done Why Is the Sky Blue? So there are things that exist in the power that are very sensitive electronics are a little bit more vulnerable to. Things like noise from, inductors, motors, things with capacitors, SCR hash, SCR is a silicone controlled rectifier. You see them a lot in switching circuits and that sort of thing. Maybe dimmer packs, triacs. There's all sorts of things that can chopped voltages, things that can put noise into our sound. And so one of the things we want to do is get that noise out if we can. Ground hums are another thing, and I want to just sort of, get right off on a tangent. Power conditioner almost certainly is not going to solve a ground loop. Okay. So that's probably something we're not going to address that today. I just don't think we have time. But there's a lot of good stuff we can do on that. The other things that can happen are over and under voltages. I'm going to send you a picture. Actually, this is good timing to think of this. See spontaneous TV right here. You can edit it in. A friend of mine, customer, just sent me the other day, literally, I think just 2 days ago. And at first glance, I thought it said 181 volts. And upon further review, it said 101 volts. In either case, it's not good. 101 is substantially below what we want, and 181 is way above what we want. So that's something we want to watch out for. Sustained overvoltages, sustained undervoltages can cause real problems. But there's also really short-term spikes or bursts, and we call those transients. So maybe another way we would call a power conditioner is a TVSS, which is transient voltage surge suppressor. We've probably heard that term, surge suppressor.
Oh, yes.
So the short answer to anybody who survived that run-on paragraph,
which is already 6.5 minutes into this show that we've had our first one.
Everybody deserves a break right here. We don't have sponsors to go to commercial break, though. So anyway, bottom line, there are really good reasons that you want to have some level of protection in your power, not the least of which being that your equipment could be sent to the happy hereafter. Maybe in other cases just simply to improve the performance of the equipment, let alone saving its life.
Okay. So you mentioned, of course, many things in that. You talked about surges and in essence brownouts and different weird sounds coming through. Let's take a look at.
You got all that.
I did. I was actually paying attention, and I actually took notes. But let's take a look at now. One of the first things that when a person's looking for that kind of protection for their electricity, they'll go and get an outlet strip, thinking that will give them a level of protection. Now, do you have an outlet strip for us to take a look at?
As a matter of fact, I do.
Okay, we're going to start at the bottom now, gang, because this is probably, when we're first getting into it and we want to protect, this would be what we do. Right there. Yes, that looks like something that I think all of us probably own a half a dozen of.
Yep.
Now, what can that do for protecting us?
Well, these can have a variety of forms of protection depending on what you buy. And I think this is where a little Latin lesson comes in, caveat emptor, buyer beware. Some of these will have basic surge suppression, which is handled by an MOV, which is a metal oxide varistor. I've got one in this device, and this device, and this device, and I'll show you later. That's something I was going to grab. It's just one out of a package, but sorry, you don't get one. So first rule of show business, never tell them what they don't know, and I just broke it. So that's what the show is all about, just the truth, telling you the truth.
Nice.
Other things, that we might have, a breaker, for example. If we have too much amperage, this will trip a breaker. Some of these will have chokes and things like that will help eliminate some noise. This one, quite literally, was taken apart just a couple minutes ago, and I didn't know any more than anybody else until I took it apart. I just grabbed this one out of a bin, and lo and behold, there's dust in it. Lo and behold, it has absolutely nothing. There is absolutely no protection whatsoever in here. It is literally from here to the breaker and straight through to the receptacles. Nada. Zip, zilch, nothing.
Now, is it a breaker that's in that one, or is that just an on-off switch?
Well, it is a breaker.
Okay.
I presume it works. Sort of the old adage about getting what you pay for. I'm sure this was expensive. I don't know where we came upon this. Maybe, it was bought to fill some purpose on an impulse moment. Ended up in, thankfully a bin of stuff that we rarely use. And when I'm done with it here, it's headed for the garbage bin. So no one around here will ever see it again.
Wow. Well,
maybe I shouldn't say it's going to the garbage can. I just think we have to understand what it's just going to be used for. It's not a power conditioner. It's not a surge strip, but it functions perfectly as a power distributor. And it's funny because actually on our NLFX brand power distribution products, that's what we call them. We call them power distributors. Even though they have some basic conditioning in there, I don't feel like calling it a conditioner. Other manufacturers put out products that they call conditioners that have the same or even less conditioning. But again, to me and for mine, it isn't a conditioner, and so we don't call it that. We call it a power distributor. So I guess that little surge strip, well, it isn't a surge strip, but I guess that little power distribution strip could live for that purpose.
So Ben, just so I can clarify here now, so that does nothing on really the power coming in to block it. But if you're on the other side and you have too much of a demand for the electricity, is that when that breaker would pop?
Yeah, absolutely. I guess we're kind of putting the cart before the horse. We're talking about some Ohm's law here. Yep. Basically, what we're talking about is the relationship between voltage, amperage, power, and the other units of measure. And I guess we can include a little bit on impedance or resistance. And we can talk about why that might be an issue.
Or, Ben, we could talk about that when you put too much stuff on one side of it, the breaker will pop.
Yeah.
You're getting into a lot of stuff, and I think that some of that we'll talk about maybe in the conditioner side of it.
Sure.
The idea is that now that's not doing anything to, again, the line coming in. So let's take a look at something now that will help us with the electricity coming in.
Right.
Let's start now. What would be, of the ones you have in front of you, which it looks like you have 3 or 4?
Yeah, I've got a couple here.
What's kind of our starter now that we want to have something that will clean the electric as it's coming in?
All right, well, this is a perfect example here. This is a very basic power distributor.
Okay.
And, we buy these black rack mount boxes, and, of course, what we see is there isn't very much inside at all.
Yeah.
Basically, what we have here is the same thing. We have power distribution.
Okay.
But what we do have is we have, if you can see the blue device right here.
Yeah.
That's our MOV. That's our metal oxide varistor.
Okay.
And basically, think about an MOV like this. When the incoming voltage gets too great, the MOV allows that voltage to pass through it like a gate. You push on it hard enough, it opens. And basically, electricity really only wants to do one thing. It wants to get to ground. And that's what the MOV does in this case, is it allows that over voltage to get to the grounded conductor, the neutral conductor. That should prevent that from going to these receptacles that we're plugged into, and very likely would cause the breaker that this is connected to trip. So or the breaker that's built into this device. I know it's somewhere here. There it is, right there.
Okay.
It also has a small noise filter in it, and it's going to help a little bit with some of the noise across the AC line. But it's a very basic, fundamental power distributor with some limited conditioning.
Okay. Now, you mentioned ground lift. That would not do anything with ground lift, correct?
No, there is no ground lift on this, and we would never want to lift our AC ground. We never, ever, ever want to defeat this conductor right here, which is the grounding conductor. Actually, we can't call it a conductor. We shouldn't call it a conductor. We have our line conductor and our grounded conductor, and then our safety ground. And sometimes people will pull this pin out, or they'll use the little 3-to-2 cheater plugs. Happy to report I didn't have one even to show you. But that's really a whole different episode. It leads me to another tangent that I'll table for now.
Yeah.
But we'll talk about safety, and we'll talk about life safety and our obligations as professionals, as people who are paid to provide a service at an event. We expose ourselves to potential liability, especially when we're doing things illegal. And by the way, send the hate mail if you want. I don't care. Removing this pin is illegal. That's just a statement of fact. So there you have it. In any case, we shouldn't do it because it's a bad idea.
Yeah.
All right.
Okay, so let's jump to the next one, because there's a lot of questions, but I think that, as you say, there's a future show with some of the nuances.
More than one.
Yes.
Let's look at a much more advanced power conditioner.
Yes.
And this one does a very big variety of things. not the least of which being it has non-destructive ways to deal with the overvoltage. I guess that's something I should mention about the MOVs. When they allow that overvoltage to pass through, they almost always blow up. They burst into flames. I've actually seen videos of these guys burning. Anyway, they're generally sacrificial, and when they pop and they're done.
Yep.
This has ways of dealing with the overvoltage in ways that are not sacrificial. The device should be able to continue to take high overvoltages. It will also shut down in an undervoltage situation. This basic power distributor has no protection for undervoltage whatsoever. It just doesn't have any mechanism for that. And that's all right as long as you understand what you got. Another thing that we have here, if you can see right here, this big black box.
Yes, I was going to ask, what is that?
Well, I'm going to be very careful touching that because it's a very large capacitor, and that means it's storing electricity. It's not a battery per se, and we'll look at a UPS in a second, which is an uninterruptible power supply, giant battery basically. Mm-hmm. But this capacitor stores power temporarily, a very, very large amperage, sufficient to end tonight's show if I touch it in the wrong spot.
Don't do that.
Everybody's hoping for that. Everybody's like, come on, do it. No,
I don't think it'll work. Go ahead, try it.
I'm not going to do it. I'm not going to do it. Anyway, so that allows us to get through some momentary brownouts. Maybe if our undervoltage is momentary, or our system pulls a bit more power than this can supply right at the moment, that'll take care of that undervoltage and allow us to continue on. Yeah. A sustained undervoltage, it's lights out,
Right.
Here we see some of the ways it'll deal with some of the overvoltages, the transients. We have here we have our one of our MOVs and another MOV here. Notably, they're wrapped, and again, that's because they are sacrificial devices. If the MOV has to be used, it's basically in here as a safety, then that MOV is probably going to meet its maker, and it's designed to keep it from doing too much internal damage. Anyway, there's some other neat features here. This board here basically runs the front panel display. It will tell you what your voltage is, how much amperage you're drawing. This little circuit board here actually powers a USB charger on the front. There's just a USB charger you can plug your device into.
Oh, yeah. Mm-hmm.
So that's what some of the other things. Down here, our switch, which is also a breaker. That's kind of the things that are going on in here. But quite a lot more and quite a lot difference in price, as you might expect.
I was just going to say, yeah, Ben, what would be the price difference now between the simple unit under your arm there and the more advanced?
Well, you're talking about $50 for this guy and a few hundred for the other guy.
Okay.
I guess they could be gals. They're not gender specific.
We don't need hate mail for those of you out there, females out there, women.
Well, I know some very, very talented and capable female technicians, and I just want to be equitable and all that. Now that we got a Facebook page, we got to do things the right way. And just for fun,
we'll start now after 30 episodes.
Oh, good Lord!
Okay, you brought the anchor in.
Yes.
Oh my!
I'm not doing this for show. It really is that ridiculously heavy, and I realize I'm a skinny little geek, but I'm fairly athletic. This thing weighs about 75 pounds, and mostly that's because inside it's a giant battery.
Wow.
And this will allow us to run our system for a very short time in a sustained undervoltage or no voltage. If the power went completely out, you could run your system for maybe 15 or 20 minutes probably with this, depending on how much your system is drawing.
Right.
We talked a little bit earlier about, ohms and watts and volts and amps. And there's also a thing called volt amperes, which is quite literally volts times amps, which would be watts if the power factor is 1, and that is a different show. Anyway, so it depends on how many volt amperes you're drawing, how long this will run, but it isn't an all-night affair, that's for sure.
Now, Ben, just so you could use.
Oh my goodness!
You could use that and actually plug your amplifiers in to that.
Yeah, you can plug everything into that.
Wow. Okay.
And it will supply 120 volt, 60 hertz AC power for a while.
For whatever, depending upon the load.
Exactly, depends on the load.
Yeah. Interesting. I guess I did not realize that existed where you could actually hook amplifiers up to it. That's pretty neat.
Well, and I'll tell you where we mostly see these being used now with mobile shows is with digital mixing boards. We don't see too many DJs using ones that size because, again, it's about 70 pounds. There are some one-unit devices that are maybe 30 pounds. Again, that adds a lot of weight to a small rack. Yeah. But with the world of digital controllers and those sorts of things, we are seeing people start to put those in. But particularly tour shows that have digital mixing boards where having that board go out could be a real heartache, particularly if it goes out suddenly and there's some damage done to the circuitry. That UPS is worth the wait.
Oh, for sure.
So
nice. Okay.
Yeah.
Let's continue on now. I see something by your left there with the little. I see blue knobs, maybe.
Yes, those are again breaker switches. This device allows us to bring in something like, in this case, 208 three-phase, and send it out as 120 volt single phase.
Ben, just give us a real quick. What is three-phase and single phase? Just give me a layman's explanation for what that is.
Three-phase has three phases. Single phase has one phase.
Tell us what a phase is.
You don't have time for this in this show. Let's think about it this way. Electricity travels in waves, and there's no short way to do this. Because people usually ask, how is it 208 and 120 all at the same time? And it just depends on where you're measuring from. It's 208 phase to phase or 120 from the peak of the phase to the neutral conductor. And everybody's eyes just roll right there. So let's just say that it does that, and it's purely magical, even though it's just physics.
It's magical.
Yeah. It comes down to the way the electricity is I guess generated and sent.
Okay, so a typical house has two
single phase,
but it has, when I've seen in our box, it's got the red and the black, yep. And those would be considered single phase.
Yep, and they oppose each other in 180 degrees. So if you went from leg to leg, black to red, you'd have 240 volts, and that would maybe drive your electric stove or your dryer. But there's no way you're ever going to get 208 out of that deal. Now, by going from the peak of that wave to the neutral, you're going to get 120, which is exactly half of 240. So that one's a bit easier for people to understand. Okay. 208, 120 is a little bit harder, but again, it's fairly simple, and we're not going to make this an electrical engineering class. We'll just suffice to say this device does it, and it's pretty simple how when we get down to it. Down here, we can see our three phases coming in. We generally note those as X, Y, and Z. In this case, we have our red and our black and an orange. Many times you also see that as a blue. There is kind of a standard color code that's used, and orange is NIP. That's what was in the cable, so there you have it. Right. Our ground here, and then our neutral here, which is our grounded conductor. And from any one of these phases to our neutral is 120 volts. And so that's what goes out to these receptacles here. And on each receptacle, we can see there's an MOV. So the blue MOV on there.
Oh, yep.
And that's that if that voltage exceeds 130 volts or whatever that MOV sensitivity is at, the MOV says, I'll take the hit, I'll jump in front of the train, and I'll save you, amplifier. Dun, dun, dun. Yeah, and splat, the MOV becomes a charred piece of former MOV. Yep. I used to have a couple of burnt up MOVs, and I don't know where they've gone over the years, but I used to keep them to kind of show people. One man's garbage is another man's treasure. So anyway, so that's a good way of, for example, my amplifier racks for my production show is all three-phase. Okay. Most arenas have three-phase, and it allows me to bring in a lot more power off of a single cable, and there's lots of reasons why three-phase is great, but that's another show.
Now, but you mentioned when you were going through there, did I count 5 wires, 5 connectors or contacts in that wire?
Yeah, you did, and we actually call it 5-wire. That's what we call it. And 5-wire typically comes in off an L21. And that's not true. Let me take that back. 5-wire comes in lots and lots of ways. So I don't want to say that, but an L2130 is one very common way that we see, and there's an L2130 right there.
Okay, so I'm seeing 1, 2, 3, 4 in a circle is the fifth pin then right in the dead center?
Yep.
Okay.
Yep. It is.
Interesting.
And of course, there's a variety of different gauges of wire, and gauges just like how we measure shotgun shells or steel or anything like that. It's a measurement of the thickness of the diameter of the wire. There's a crazy, ridiculous formula for figuring it out if you're just dying to know. I actually did that on an industry group one time. Someone was asking about the difference in wires, and I just at random went and grabbed a off-the-shelf cheap Chinese-made wire, and then I grabbed a quality American-made wire. And that's, it's not a statement of politics, but just sort of, I think sometimes we trust too much what's coming from overseas. And found that the wire that was being sold as 12 gauge was in fact 14 gauge, which is smaller. So it wasn't as big as the package said it was. And I was able to do that using a caliper, a measuring tool, and the formula. But anyway, here's a good example. I got to keep this under 2 hours for nobody to watch. This is your standard, what you'd find in your walls at your house or business, probably go onto your receptacles. Standard 12 gauge solid copper THHN wire.
Okay.
And here we see a 4/0 wire. And you can see it's just substantially bigger. There's a lot more copper there. Mm. And the bigger pipe is going to allow us to send more electricity down. Now, we can push a lot of wire, or a lot of power down this wire. But of course, there's an old saying that I'm fond of, and that is, what do you call a wire that's too short and too thin? A fuse.
That would make sense.
So,
because it's going to burn up and.
Yeah, and that's because the kinetic energy of the electricity, the electrons banging into each other and whatnot heats that thing up, and anyway,
yeah.
Of course, sooner or later, poof, right? Mm-hmm. Poof goes your MOV, poof goes your wire, whatever.
Yeah, very cool. That's interesting. So we looked at the 5-pin connectors. What are some additional? I mean, I've seen a lot of different electric connectors. I mean, on the back of speakers, we're starting to see things with a. What do they call that? Where it clicks in and turns. Yes. What are those?
It's like I read your mind. This is what's called Poweron, and it's different from Speakon. It's made by the same people at Neutrik, but it's different. Okay. And you're not supposed to be able to fit one into the other. I've seen it done with a great deal of force. Sort of the old saying, if it doesn't fit, use a bigger hammer. Anyway, it doesn't fit unless you really do something awful. But a Poweron, just like a Speakon, is, and this is a 120 volt version here, is a locking connector. So the nice thing about that is that is now locked in there. It's not going to come out accidentally. And blue is for power in, and gray is for power out.
Ah, okay. I was going to ask about the colors.
Yep, facilitates things like power linking. Now they have a whole series of Powerons. I'm just going to stick with the simple ones that we see every day, but there's actually quite a few choices.
With that wire, hang on to that wire for a second, Ben. Is it possible that, say if you had that plugged in to the wall, is it possible that a little finger could get in there and get a shock from it?
Has to be a really small finger. But it is possible if you stuck something in there that was, conductive and curved. It is possible you could touch those conductors and cause a short.
But it's no more dangerous, or even less dangerous than a traditional cord, I would guess, the way it was looking.
Oh yeah, I would argue that. Yeah, I think it's very safe, and typically these are in the hands of professionals. Now that's not to say again that something catastrophic couldn't happen, but it is it's one of my favorite connectors, yeah, for sure.
And I think we're seeing more and more of that on mid to higher end lighting and speakers.
Yeah, I love the locking aspect of it. They're built really well. They're built very solid. They're easy to service, which in the field is really important. Of course, we see our standard NEMA 515. That's something I think everybody's seen probably every day of their lives. Maybe some of our overseas viewers, this might be something new to you, but it's how we do it in America.
That's right.
I saw my Facebook post the other day. I was drinking coffee while running on the treadmill. America. Yeah, that's So you know your day's off to a fantastic start right there. Two things done at one time. This is called a 515P in my hand because it is a NEMA Class 5 15 amp plug.
Okay.
And the opposite of this, of course, is a receptacle, 515R. Some people have maybe seen, like what's on the other side of this, which has a horizontal slot and a vertical slot.
Turn it just a little bit towards us more, Ben. There we go. There we go.
All right, so you've got a horizontal slot and a vertical slot
now
instead of two vertical slots.
What's the significance of that horizontal slot? What does that do?
This particular connector is designed for 20 amps as opposed to 15 amps. And so if you had a device that's drawing 20 amps of current or is rated to draw, up to, over 15 amps, then we would use this type of connector. And actually this cable is an adapter for if you needed to plug this 20 amp device into a 15 amp circuit. And on the face of it, it sounds like a pretty bad idea. And it can be. It's definitely something you should know what you're doing. You'd have to know that you're not going to exceed the 15 amps with what you're doing. Maybe you have an amplifier that could draw a lot of power, but you're not going to be using it that hard, and so it's not going to draw that much power. This is a UL-listed manufactured solution designed for that. So it is an approved means, an approved method, again, as long as you're not going to exceed 15 amps. If you do, the breaker's going to blow, and you're not going to be able to use it anyway. So. And
you mentioned some amplifiers might have that 20 amp connection. Are there other pieces of gear that you've run into that would have a 20 amp connection like that?
Yeah, actually, sometimes it's the power conditioner itself. Now these both have 15 amp, but there are power conditioners that are rated for 20 amp output, so they have 20 amp input. Oh. And again, if you said, well, you know what, I'm not going to use it for 20 amps today, but I got to plug it in, and I don't want to chop the end off because now I've taken away the UL rating of that device. Now I've done something I shouldn't do. That's a UL approved way of doing that if you're not going to exceed that current.
Nice.
Yeah. Speaking of things we shouldn't do, we'll go back and kick this dead horse one more time about removing the ground pin, because some people don't have a choice in that the ground pin was already removed for them or it was never there. I hear this a lot in some of the older buildings, particularly in the Northeast Seaboard, where they say the outlets don't have three prongs. I can't plug in a three-prong device, so I get one of those old cheater plugs or I break off a ground pin. And again, don't do that. It's not safe. It's not legal. But again, you're saying, okay, well, fine, smarty pants. What do we do? Because we don't have the ability to do that. And the appropriate way to do that, if the venue isn't going to change their outlets, which they're probably not, right, is we'll solve it on our end by using a portable GFCI. GFCI is a ground fault circuit interrupter. And here we have this inline GFCI, very similar to what you would find maybe by a wet location by your kitchen sink or your bathroom.
Okay.
We have the test button and the reset button. And now here the GFCI has 3 pins. Yeah. But in this case now, I wouldn't find using a cheater plug or a 3-to-2 adapter objectionable because we're using this GFCI to address that problem. The way we would do this. And again, probably a good time for a disclaimer that our show is not, we're not giving advice on how to wire houses, and do everything you do at your own risk, yada, yada, yada. Don't. If you
have comments, go to Twitter or go to our new Facebook page.
Whatever dumb thing you do, I'm not responsible. How about that?
Don't tell us about it too much.
Yeah, tell us about it if you survive, but...
take a picture of the burning, but...
Yeah, I could use more what were they thinking pictures. Anyway, the way we would do this in a permanent wiring application is you would put in a GFCI where there is no grounded conductor, safety ground available, and so we only have those 2 conductors coming in, and your GFCI then would be marked with a sticker that says no equipment ground. So a person knows that, look, there might be a 3rd prong on there, but it doesn't go anywhere. And the GFCI is then detecting and protecting us from ground faults, which of course there isn't a ground, so it's looking out for us there.
Interesting.
Yeah, that, like I said, disclaimer, have a licensed electrician do that, okay?
Yeah, that's not something that the just regular Joe DJ. We don't tackle those types of things.
Well, and definitely don't go digging into your venue's wiring. I can't greenlight that for you.
What are you doing back there? Nothing.
Yeah, even though you're doing them a favor, you know.
There's no ground wire back here. What are you doing?
Also, if you're working in wet locations, if you're doing anything outside, you know, anytime that you're concerned, you know, have a GFCI is a pretty good idea.
What does something like that run, Ben? Ballpark.
I want to say like $20 or $30. Oh. It's pretty minimal when you think about the alternatives. And you know, this is a good time to get on my soapbox. This is something new, and I really want to do a show on this. I mean, it's new as of February, but it's new to a lot of people still. You know, it takes some time for the word to get around. I think most of us are familiar with some of the rigging tragedies that occurred. The Indiana State Fair comes to mind, and there was actually 3 that month that had fatalities. Mm-hmm. And then, of course, you know, a few years ago we had the Station nightclub fire, which is a real tragedy. I think 100 people died. And, you know, what struck me as so meaningful about that, when I looked at the video and the pictures of that fire, you know, the first thing, I guess, that struck me was what an avoidable tragedy. But the second thing that struck me was even more powerful than the first. And it was, boy, this is just an average bar. This looks like every other small, you know, roadhouse bar I've ever seen. You know, I mean, it could have been anywhere. It could have been you. It could have been me. Yeah. You know, we could have been working. We could have been guests. But anyway, our industry has really taken some steps to do things better, to do things more safely. And I have no affiliation with these folks. But I tell you what, it's an organization I want to learn more about. Yep. The people that are involved are the major players in production, and I think we as DJs need to take a proactive approach in you know, taking ownership and taking responsibility for the safety of our events. Yeah. We're the ones running the show, quite literally. We're the ones with the microphones. And again, that's a future show I want to do. But I just tell you what, all these things that we talked about, you know, using best practices and professional responsibility. That's something we can start doing immediately. Yeah, for sure. We ought to.
Good stuff, Ben. Good stuff.
Who knew I had a soul?
Wow. Now, for those who are really wanting to do some more research and wanting to learn more about a lot of the different aspects of electricity as it relates to what we do on a regular basis, if there was only a resource that a person could purchase.
All right, now I put you up to that. So, but in all sincerity, you know, because once a week just might not be enough. You know, you need your Ben Stowe fix, right? Everybody just. All right, I'm done with this. I've had with this guy.
Our viewership just went.
All right, really, I'm humble of heart, but with that humility, I tell you, there's some pretty cool stuff on here, and we talk about with some great, clever graphics. Not that yours aren't good, John, but this was professionally produced, professionally shot, you know, studio and fancy computer graphics and all that fun stuff. Yeah,
and costumes.
Yeah, I actually wore a white lab coat. And here's a little bit of trivia that maybe you don't know. Some people noticed that the lab coat said Stowe on it. It isn't mine. It was actually my dad's. So there you have it. My dad actually did wear a lab coat professionally. But some fun stuff we did in here. We took, you know, we talked about these wires and what happens when you put too much power through them. Well, we took a FLIR camera, forward-looking infrared, a camera that basically allows you to see heat. And we took a couple different gauges of cable with the exact same draw, and we heated them up. And we did so in a fire station, actually. We did it in my local firehouse, and we had firemen just looking at this. And it was amazing because we were shooting that part of the DVD right around the holidays, and all of a sudden, I think every Christmas light fire just made sense to everybody. And again, they're avoidable tragedies, you know. Anyway, and as a bonus, this just makes it worth buying a DVD. They took a fireman who'd been there like 3 days, brand new rookie, and they said, hey, interview him for this DVD. So we did. He had no idea we were going to do that. And you can just see the fear in his eyes. It was hilarious. But beyond that, there's you know, a couple other fantastic professionals on here. Some people who make some appearances that are absolutely Mike Cronin, absolutely A-list. We had him. He was the guy on the beams with the cupcakes for his birthday party.
Yep.
He's an A-lister in the tech world, and he's on here showing some proper, coiling and maintenance of cables. My friend Jim LeClaire, who spent 40 years in the electrical trades, 25 of those as a state electrical inspector, he's on here. So it's not just me. And, I want you to buy the DVD, but for the right reasons. There's good content on here, and certainly it's educational, but it's not entertaining.
No, and as I've watched the video, and I have to say I've watched it more than once, because it's one of those things that there's so much information on that video that you watch it and you'll pick up some things, and you almost need to digest.
Yeah.
And then watching again. And I think you've just got so much into that it's really.
Well, we chapterized it for that reason. You can take a chapter, kind of digest it. I have people email me with questions, and it's great because as I answer the questions and as they come back with another question, you can see the progress. You can see the progression they're learning, and they go from not a clue to getting it, and that's what it's all about. It's about sharing that information. So, thanks for saying that, John. But it's not an epic. Yeah. I had one guy who's a friend, a guy I respect a lot. He said, well, it's a little dry. What's a technical training,
Yeah, exactly. There's a lot.
I'm not funny. I'm sorry. I'm not handsome. I'm not funny. I'm not entertaining. But I'm going
to keep you from burning your Christmas display.
It's the DVDs are distributed by Alfred Publishing, which is the largest distributor of educational musical materials and sheet music and that sort of stuff. And it's sort of like a record deal. It's kind of a weird situation. I make virtually nothing on a disc. I think I make $1 or something. It's like a record deal. But anyway, when we were pitching the idea for this DVD as a follow-up to the lighting DVD, my rep at Alfred Publishing said, well, who needs this DVD? And I said, everybody. And that wasn't an arrogant or overblown statement. My mom every Christmas has 15 roasters plugged into one outlet, and the circuit keeps breaking. She doesn't understand why. She has no idea.
Why is this not working? It should be working.
I said, Mom, you need this.
What's this?
You need to understand why you keep blowing breakers.
And then she's like, I watched you for 18 years. I'm not gonna.
Well, actually, what she said is, listen, if you want the apple pie, you'll get it to stop happening. And so I rearranged stuff, and I concede that we all have different talents in this world, and mine are technical, and believe me, I can't cook, so I make it so that she can do what she does best. She's a wonderful cook. I have a fantastic mom, and you know what? I know she doesn't watch this show, so I'm saying that from the bottom of my heart. But I make sure that the breakers don't blow.
It's not the holidays unless Ben's got his tool belt out and rewires the house.
Man, I'll tell you what, you want a Christmas special. We got the Griswolds have nothing on us.
Oh, good stuff. Good stuff. Well, as we mentioned earlier, if you've got some questions, some comments, some thoughts, you can pop out to Facebook. You can do a search for Tuesday Night with Ben Stowe. Get to our Facebook page. Put your comments, your questions, because this link is going to be there. You probably found this link somewhere else, but it'll be there. Put your thoughts there. Ask questions. Or Twitter. Ben, what's the hashtag to get you on Twitter?
Hashtag NLFXBen. And that's great, or the @NLFXBen. But I'm excited about the Facebook page. I think I'm glad you did that, John. That was a good move. That's going to give us the ability to, really interact with people. And, here again, another great revelation for the viewers, but I'm not compensated for doing this show. I know you don't really make anything off doing this show. We're committed to the betterment of our industry. We're committed to education. And, I tell you what, it's cliche, but I'm committed to saving some lives.
Yeah, I think that's a good point. A very good point.
So I'm glad to see that next level of education, that we can help people become just that next level. They bring the talent, they bring the charisma, they bring the ability to mix and all those sorts of things. What they do as entertainers. There's a lot being asked of a DJ, though. Yeah. You're not just the entertainer, you're the technical director, you're the roadie, you're all things. And I want to help you do it just a little better. Yeah,
good stuff. If they want to order the DVD, how can they find that?
You can go to proacademyseries.com and you can find a list of dealers. They are available in, I think, 19 different countries. Of course, you can order them directly from NLFX Pro as well. But I don't want to take anything away from the other outlets that are selling it. We sure appreciate them. And we can put the link in on the Facebook page too.
Yep, we'll put it there we'll put the links down below the video so they can check all of that out. Great. Well, Ben, thank you very much for another great show.
Thanks, John.
This is John Young with the Disc Jockey News and Disc Jockey News TV. Good night.